Now I'm going to implement the actual algorithm here in this tutorial. Okay, so we need a stack for this purpose, so I'm declaring a stack object here. We need to initialize the stack top to -1, and we need a variable error. Initially we are assigning 0 to this error variable, as we are considering that no error is there in the expression, and we will scan through the expression. If we find any error, we will just assign 1 to the error. At the end of the function, we will check the content of the error. I mean, this function is going to return the content of the error to the caller. So we need a while loop, and for that we need a loop counter, and this while loop is going to scan through the expression. So as long as expression I expri not equals null, that's the end of the string, we need to iterate through the while loop. The next char is the next character of the expr, so we need to get the next character, and now we need to check the content of this next char. And that is just what we did here in the algorithm. You must remember this. If it is opening bracket, either of the opening brackets, then we need to push it into the stack. If next underscore char is opening parenthesis, or next underscore char is opening curly brace, or it is opening square bracket. If either of these three, then we need to call the push operation. You need to pass the address of the stack and the character that you need to push into the stack, and that is next char that contains the opening bracket. Else if there are next char is a closing bracket, let me just copy. Okay, we need to change it to closing bracket. Here is a closing curly brace, here is a closing parenthesis. Now if you get a closing bracket there, first of all what we need to do is to check if the stack is empty or not. You must remember the algorithm here. You see that if either of the closing bracket is encountered, then we are checking if the stack is empty. Now if a closing bracket is there and the stack is empty, it's the error. So if is empty stack, then obviously it's an error. So what we are going to do, we are going to assign 1 to error, and we are going to break the loop. Otherwise, let us check the algorithm. Otherwise, if it is matching with the stack top, then we need to pop the stack. So we need to call the isOpeningMatch function. So we are calling the isOpeningMatch, and the left hand side is the opening bracket that is on the top of the stack. So we are calling the stack top and passing the address of the stack there. That's going to return the top of the stack, and next char is the current character that is containing the closing bracket. So if they match, then we are going to call the pop operation. That's going to pop the stack top. Otherwise they do not match, that means it's error. So error is 1, and we are going to break the loop. So this is how it's going to work. Now at the end of the loop, you need to test. If no error, that means so far you do not have any error, and still the stack is not empty, that means excess brackets are there. Is empty, not is empty. We are calling the not is empty function, and we are using the not operator there. Then the error must be assigned with 1, and then at the end what we need to do is to return the error. So the content of error is either 0 or 1. If there is any error found while scanning through the input expression, then it's going to be turned on to 1, otherwise it will remain 0. So this is how it is implemented. Now I will just run this and I will test whether we have done it correctly or not. And before we do that, there is a silly mistake. We need to increment the loop counter. Okay, so I must be incremented so that it could get to the next character there. So now let us check this program, whether it works correctly or not. I will move to the terminal. I have saved this program there at folder Udemy. You can see that it's /udemy/check_bracket.c under the home directory. So I'm opening the terminal. My present working directory is the home directory, and I will change to Udemy. So my program is here. You can see that check_bracket.c is situated here. So now I'm going to compile this gcc space check_bracket.c. I'll compile this. Compiled successfully. Now it has produced the a.out file. So you can see that a.out is there. Okay, so I'm going to run this /a.out. Let me give a good expression at the very beginning. And you can see that contains well-formed brackets. The program is working fine. Let me run the program once more and give a bad expression there. Okay, it is working fine. Let me test with some other values. Say we are giving 1 plus square bracket 2 minus curly brace 4 minus 2 curly brace closed. Then again I'm giving a closing parenthesis. That's a bad expression. Okay, so it's working fine. You can test with some other values, other input expressions, and you can go through this. I'd like to recommend a modification there for this program, that is as a task. If you see that this program is not going to check the precedence of brackets, the parenthesis should be within the curly brace and the curly brace should be within the square bracket. That is the precedence of these brackets. But this program, our program so far we have developed, is not going to check the precedence there. That means if you are giving something like this, a plus, first we are giving a opening parenthesis, then 4 minus, we are giving a curly brace, and that should not happen, right? We cannot put a curly brace within a parenthesis. A curly brace should be out of the parenthesis. Parenthesis should be the innermost bracket. So, but so far what we have done is not going to check this. It's going to be okay. But I want you to develop the logic so that it actually flags error as far as the precedences are concerned. That means if your program contains a parenthesis within a curly brace or a curly brace or a square bracket within a curly brace, it's going to flag error. Try out that. If you need some more idea regarding implementation, you can just always ask me in the forum. Thank you very much for watching. Hope you have enjoyed that.